Welcome to qnawire.
Hello students. In this question, a rocket uses two different kinds of fuel. One is ammonium that combine with the perchlorate ion and another one is the liquid hydrogen and the liquid oxygen. We have to find out the energy released during the combustion of these two fuels. So for that, we are using the del H of the reaction formula, which is given by the summation of the del H of the product minus summation of the del H of the reactant. So for the first equation, we are going to derive the del H expression. The del H of the reaction 1 is given by the 3 into del H of NO plus 6 into del H of H2O plus del H of Al2O3 plus del H of AlCl3 minus 3 into del H of aluminium plus 3 into del H of NH4ClO4. Now we are going to substitute the values from the table, that is 3 into 90.3 kilojoule per mole plus 6 into minus 241.8 kilojoule per mole plus minus 1675 kilojoule per mole plus minus 700 kilojoule per mole minus of the del H of aluminum will be equal to 0. Then 3 into minus 290. On solving this, we will get the del H of the combustion of the first fuel, that is aluminum with perchlorate ion, will be equal to minus 3226.5 kilojoule per mole. Now we are going to calculate for the del H for the combustion of the secondary fuel. The del H for the combustion of the secondary fuel is given by the del H of the formation of the water minus del H of formation of hydrogen plus half into del H of formation of the oxygen. So since it is a diatomic gas, the del H for the formation of hydrogen and oxygen will be equal to 0. Then the del H2 will be equal to the del H of the formation of the water, which is equal to minus 241.8 kilojoule per mole. This is the answer to the first part of the question. Coming to the second part of the question, we have to find out the energy to the mass ratio. So this is given by the, for the first equation, it is del H of the reaction 1 divided by the molar mass of aluminium plus molar mass of ammonium chloride. So now we are going to substitute the value according to the equation, that is minus 3226.5 kilojoule per mole, as there is 3 aluminum present in the equation. 3 into 26.98 plus 3 into 117.49. On solving this, we will get energy to mass ratio of the reaction 1 will be equal to minus 3226.5 divided by 433.41. On dividing this, we will get the energy to mass ratio of the fuel 1 will be equal to minus 7.44 kilojoule per gram. Coming to the second equation, energy to the mass ratio of the second equation is given by the del H of the reaction 2 divided by the molecular mass of hydrogen plus molecular mass of oxygen. Substituting the value, that is minus 241.8 kilojoule per mole, 2 into half of 32, as half mole of oxygen involved in this reaction. On solving this, we will get minus 241.8 divided by 18. On solving this, we will get the energy to mass ratio of the reaction 2 will be equal to minus 13.43 kilojoule per gram. Coming to the last part of the question, we have to give the environmental concerns for the fuel 1 and 2. So coming to the fuel 1, the fuel 1 release the exhausted product of Al-Cl3. So this has a chloride ion. This chloride ion will combine with the hydrogen molecule in the atmosphere and forms the HCl. So this is the principal source of a acid rain. Coming to the second fuel, that is fuel 2, liquid hydrogen and liquid oxygen. So these two combine to form the water molecule, which is an environmental friendly liquid. So that this fuel is highly eco-friendly rocket fuel. Rocket fuel. This is our answer. Hope you find this video useful. Thank you.